Now we'll discuss insertion. Okay. So here we have three cases. So case one is I can insert my new node at first position, right? Okay, already in my list I have one node. The name is 5. Next value is null. The address of this node is 100. And the head is also pointed to this node. Okay. One more node I want to insert here. Okay. That should also at the front position. So for that, for new node, we have to allocate to a structure, allocate to a space also. Okay. You take assumption this node name is I'm going to maintain as a T1. So here I can call it as, otherwise you can take it as a new node itself. Okay. So I'll call it as a structure. So struct node star new node. Okay. Allocate a space also. So new node is equal to malloc size of that node. The structure allotted and space is also allotted. This is my structure, right? So now I'm going to fill the remaining two field of my new node. So the first field is data. How can I access the second field? New node, arrow, next. Okay. You can give it as this 2. This one is I'm going to, this value is 2, right? This is I'm going to consider as the first node, right? So where you have to join this node, you are already the first node address. If you are giving here, so automatically this pointer is pointed here. Okay. So that meaning is you can copy the first node is always pointed by head node, right? So I can call new node dot next, new node of next is equal to head. So here I'm assigning 100 to this place. So our pointer is pointed like this. Now this is considered as a first node. The next node is, the first node is already existing first node is now considered as the second node. Okay, one more thing you have to do, right? So always the head pointer pointed to the first node only. Now it's pointed in second node, right? So what I have to do, change this head position to the new node. So you can give it as head is equal to new node. Now this will be erased. Your head is pointed to the first node. Now you can check your list. The first node is 2, second node is 5. Okay. Okay, then we'll see the next case. Insert at last. This is case 2. Okay. So my list is already our two values, right? One is 2. This is pointed to the next node as 5. This is null value. This is address is 100. This is address is 200. Head is pointed here. Now I want to insert one more node that should be at last position. Okay. So for that, I need my new node. So I take assumption. This is my new node. I'm going to give a value also this place, and I'm going to give a null value because this is the last node, right? I'm going to insert. So it's a next value, sure, it should be of a null value. So here itself I'm going to maintain as a null value. So First, I can copy the structure to my new node. Okay, where I have to insert this new node? Last position. I don't know where it is available. I know the features, right? How can I find the last node? The last node next field is null, means that node is called as a last node. Okay, which node is our next value is equal to null, means that is a last node. It's very simple. We can easily track that node. So what I have to do is you have to start from the first node. First node is already pointed by head node, right? You can start it from the first node. Keep on, you can check that next value. Okay. If the next value is not equal to null, means move a traversing pointer to the next node. Whenever your next value is a null, you can stop your traversing pointer in that position. Okay. After that, you can insert the new node at that position. Okay. So for that, for traversing node, I'll maintain one more pointer as a T. So next you can give a space also. New node is equal to the malloc. That you can fill it. Okay. Next, I can fill the two places. New node of data is equal to 20. New node of next is equal to right. So now I'll start my traversing pointer. Where I have to start? Always starting from the first node, right? So first node address, I can take it from head. Now we're traversing pointer this position. Okay. What is the condition here? How to check it is the next value is not equal to null, means move a traversing pointer to the next node. If it is null, I have to stop. So keep on. Suppose you take assumption you are having 100 nodes. So which one is the last node? If your list is having 100, the 100th node is the last node. So for that, how many times I have to move a traversing pointer? 99 times. Okay, for that, you can go while loop. Keep on, we have to check out, right? So for this, T of next is not equal to null. Okay, here you can check it. What is T of next? This position, right? T of data is this value. T of next is this value. This value is actually 100, right? That is the reason this is pointed to the next node. So this is 100, meaning is you are checking 100 is not equal to null. Yes. That is not equal to null. That is having some address of next node. For this, mover T pointer is equal to next node. So how can I move my T pointer? You have to, now your pointer is pointed in 200, right? Now you want to change this 200 to 100. So that's very simple, right? So you can give it as, how can I access this 100? So you can take it as T is equal to T of next. Now where T value is, the traversing pointer value is 100. So your pointer is move to this position. So initially pointed in 200, now it is moved to 100. Again it will check 100 of next is not equal to null. What is 100 of next? Actually that is equal to null, right? There is no value is there in this position. That situation, what will happen? You have to come out of the loop. Okay. Now you are traversing pointer at last position. It's very simple. You can insert your new node this particular place. How can I access this place? If you are making, you take assumption this is 500. If you are changing, if you are allocating 500 here, means your pointer is automatically point to the new node. So how can I fill 500 here? So T of next, right? T is pointed here. So you can access this field using your traversing pointer. So T of next is equal to new node. So 500 is placed here. So automatically your pointer is point to the next node. Now this node is inserted at last position. Okay. Let's see the one more insertion. Inserted middle. Okay. So I have a three nodes, right? One is 1, 2. This is 5. This is 20. The last node, null value. The address of this one is 500. This is 100. This is 200. So head is pointed here. And this is 100. This one is 500. Okay. Now, so my new node is, I'm going to give here, this is my new node. Okay. I'm going to give a value here is some 25. This is I'm going to give it as a null value. For this middle position, so I have to read which position you want to insert your node. Okay. So I have to get position value from the user. You take assumption. In this example, I am going to insert at a third position. Third position in the sense this is a first position node, this is the second position, third position means here. So in between of 5 and 20, how to insert your new node here, this place. Okay, for that, what I have to do? Do we need any traversing pointer? Yes. Okay. So how you have to traverse from the first position? How long you have to traverse? Till your position -1. This is third position means before this position, you have to stop your traversing pointer. Your traversing pointer is here means easily I can insert my new node this place. Okay. So we'll start the structure. Struct node. First one is your new node, followed by the traversing pointer. Okay. Unallocate a space also. You have to get the value for your position also. Use some scanf statement, you can get it. Okay, here simply have taken position is equal to 3. Okay, listen. So first you can allocate your new node to field. New node of data is equal to 25. New node of next is equal to 9. Okay. So the address is this is 6.5. Now you have to traverse, right? So for that, my traversing pointer starting from my head node. Okay. You can use while loop or a for loop. So here I'm going to use a for loop for I is equal to 1. I less than position -1. Before position, I have to stop. So that reason I have given here position -1. If this condition is true, move a traversing pointer to the next node. So how can we move? T is equal to T of next. Okay. For example, here you can take it. Your traversing pointer is here using this line. Okay. Next, it will check I value is 1 less than position -1. Position is 3, right? So that is 2. Condition is true. So your T pointer is moved to the T of next. T is pointed to 100. So here, the second. Again, it will check the I is incremented by 1. So now I value is 2 less than position -1 is 2. Actually, this is false, right? it will come out of the loop. Now, wherever T is pointed, the second position. What is your position you have given? 3. So, our algorithm is true, right? So, you have to stop your traversing pointer before the position. Then easily I can insert my new node. Now, your traversing pointer is here. Very simple. What is the changes you have to do? Here I have to do this address, right? The 500 should be placed here. 600 should be placed here. Then your link is pointed here. This link is pointed to this node. Okay. So how can I take this 500 to this place using my traversing pointer? Easily I can take it. This place only my T is pointed, right? So 500 I can access T of next. Okay. So new node of next is equal to T of next. Here 500 is placed. That meaning is this pointer is pointed to the last node, the third position node. Now here is also you have to remove this link. For that, what you have to do? Remove this 500. You have to represent this 600 here. So how can I change it? So I can access this field also, right? What is the name of that field? T of next. That is equal to your new node. Now 600 is placed here. That meaning is this link is erased. This is pointed to here. Now my new node is inserted at third position. There's the first position, second position, third position. Okay. Thank you. Insertion is over. Deletion we'll see in the next video.